Hey everyone, I'm Maddie Thompson from ClearPath Robotics, and this is the second video in our TurtleBot 4 tutorial series. Now today we're celebrating the launch of TurtleBot 4 by delivering some donuts to our TurtleBot development team. In this video, we'll be teaching you how to create a map of your environment using your robot, as well as how to navigate that map using the ROS2 navigation stack that comes on your TurtleBot 4. Now let's get started. So before we begin, if you're new to TurtleBot 4, make sure to check out our previous tutorial and we'll walk you through all the steps to get set up with your new robot. Otherwise, today we are using our TurtleBot 4 standard model, as it's got this mounting platform for which we've designed and 3D printed a donut holder device that snaps right onto the top. And if you are looking for the design files for this, they will be linked in the description below. We've also got a computer that's running a Linux environment, as well as a package of a half dozen donuts from our favorite local donut shop, Lady Glaze. Now that our robot's turned on, we're going to go ahead and launch our SLAM toolbox, and we will do that by opening a new terminal and running this line of code. Now SLAM will allow our robot to create a map as well as localize itself within a map at the same time. There's two different kinds of SLAM that are supported by the TurtleBot 4. There is synchronous and asynchronous SLAM. Today you'll notice we're using synchronous SLAM, and this will use a little bit more processing power, but it will help us to create a better quality map overall. Now after we've launched SLAM, we're going to go ahead and open another new terminal and enter this line of code to launch RViz. And RViz is a program that will allow for us to view our robot as well as its location on our map when we're both generating the map and navigating today. Now we need to create a map of our environment for our TurtleBot 4 to navigate. To generate your map, you will need to place your TurtleBot on the ground and use your controller to drive it through your environment. You can monitor its completion by using RViz. Now, two important tips to consider is to clear out any objects in the area that are below the lidar of the TurtleBot, as it's a 2D sensor and therefore won't be able to see them. Also, just try not to have anyone walking around while you're mapping, as they could show up on your map. Now the robot is using the integrated 2D LiDAR to build the map. The LiDAR is scanning 360 degrees and can detect objects up to a range of 12 meters. The red marks on the RViz map indicate the objects that the LiDAR is currently detecting. Now that our map has been created, we will save it by running the following line of code. Once the map is saved, it will generate an image file with this naming convention, and it's always good to give that file a check and make sure you covered all the areas you want to navigate. Also, a file with this naming convention is created, which we will reference when setting up our navigation in the next step. So now that we've saved our map, we can go ahead and create our donut delivery route. So we'll do this by launching the ROS nav2 stack using this line of code. And just note to replace the map name in this line with your map name you saved it with in the previous step. So the first donut we're going to be delivering today is to Trevor, our TurtleBot 4 builder. We'll get out our donuts. And load it on top of our TurtleBot. There. Awesome. So now we're going to open up RViz in a new terminal using this line of code. And at the top of the window, we're going to see three different buttons. The first button on the left side is called the 2D pose estimate, and we will use this to set the approximate initial location and orientation of our robot, or the pose of our robot. Next, we will click the nav2 goal button, and we will set our goal pose to the robot to be over by Trevor's desk. Once we click that, the nav2 stack will start right away and create a path towards your goal pose and navigate the robot over to the goal. So our next donut is going to go to Adrian. He's our Turtlebot 4 mechanical designer. So we're going to go ahead and load that up on our Turtlebot and send it on its way.
The red line shows the planned path of the robot, taking into consideration obstacles. The robot is constantly evaluating its path and will try to find the quickest way to its destination. As well, you'll see the light blue bubbles along the walls. These bubbles have the same radius as the robot and show where the robot can't drop.
So now we've officially successfully completed 2 autonomous navigation missions with our Turtlebot 4. Hopefully Trevor and Adrian are off enjoying their donuts right now. Now that is it for our tutorial today. However, if you'd like access to some more tutorials or today's tutorial in a written form where you can copy and paste the code, there are links in the description to help you do that. Now make sure to stay tuned to our YouTube channel because there will be some more interesting robot videos coming very soon. Don't forget to like if you enjoyed this video today, and if you've got any questions at all, make sure to comment those down below. Now, our Turtlebot's got to get back to work delivering some donuts. However, before it does that, I might just take a look and maybe just set one aside for myself. Now, thank you all for watching today, and I'll see you next time.